Okay. Okay, just a little bit of housekeeping. So I've just released the coursework. It isn't hard. Don't panic. Have a look on Moodle if you want to see what it is. You've got until the 13th of May. So plenty of time to ask me questions. Now, the only thing I will say is there are 3 questions on the coursework, 2 of which require answers of 500 words, 1 of which requires an answer of 1,000 words. That question is about the server you'll be looking at in the next lab. So that's why you can't understand or answer that question this week. Okay? So please don't email me saying, I don't know how to answer the last question. I know that I just gave you an extra week of looking at it. You'll be able to answer it next week. All right? So don't worry about it. Obviously, you can just ask me any questions you wish. I've done some sort of frequently asked questions at the bottom, like where am I on word count and things like this. So hopefully that will give you some answers. Okay, so we're near the end. We're on databases today. And then on Thursday, we're going to look at intruder detection. Then on Friday, we'll have a revision lecture. Then we'll stop. And then after Easter, maybe we'll have another revision lecture when people have actually done some revision, maybe, and know what they got stuck with and things like this, and you can ask me. But if there are topics that you want me to cover in a revision lecture, just email me and ask, right? Because I'll just do that. That's fine. If you don't ask, I'll pick some hard topics or something. But not that many people email me about that, so if you do, you'll probably get your topic covered, so Okay, so today we're going to talk about database security. Now, I'm not going to spend a huge amount of time talking about things like privileges, because you will have already covered it in year 1. But at least I hope you have. However, we will look into them briefly. Right? Then we're going to talk about things like views, and how they can give you some security, essentially controlled invocation for databases. And then we're going to look at statistical databases, which is perhaps something you haven't come across before, but something that maybe is a big deal in research, and how hard it is to protect statistical databases. Right? And then finally, we'll look at SQL injection because it's fun. Good. All right, so think back to the operating system lecture. And in many ways, operating systems are quite data-oriented, right? We're mostly worried about which files we can access and who can access those files. What's actually in the files is kind of not that important, right? So we never make a decision at an operating system level of this file could normally be read, but it's got this information in, so you can't read it, right? Things like mandatory access controls, top secret stuff, that's, for things like SE Linux and other operating systems. Right? Now, database security is kind of different because it's almost entirely based around what information you're allowed to see and what you aren't. Right? We often don't think about the actual data in the actual rows and the actual files underneath. We think about what columns can you view, what columns can you update, right? What can you delete, what can you not delete. Right? So we're talking about content in the database rather than just a list of files. Right? So this means there are lots of similarities between SQL and database security and operating system security, but on the other hand, it's kind of role-based. It looks a little bit different. Right? Hopefully, you'll be familiar with some of this stuff. We're going to have a whistle-stop tour, so let me know if you get stuck. Okay. So, just like with operating systems, where we had owners and users, operations, and the principals, operations and objects, we rename them slightly for SQL. Right? So we have users, these are the people who are logged in, or the accounts that are logged in, or the processes operating on our behalf. We have actions, so things like select and update. And then we have objects, which are the relations that we're looking at. Right? A relation is a sort of theoretical name for a table, but it's basically a list of tuples. Right? So you have some amount of attributes, columns, and some amount of rows or instances of those columns. Right? And so users invoke actions on the object. So you can select some amount of a table, or you can join 2 tables together, or you can update certain rows in a table where a certain condition is true, and things like this. Right? And usually we use SQL to talk to databases in this way. Right? It's not, you don't have to, it's not really important. But we're going to focus on SQL because it's still obviously massively prevalent, and I would be surprised if you don't all at some point end up having to write some SQL in a job. It just comes up a lot. Right? Much as we'd like to avoid it. Okay. Now, in SQL, unlike the defaults in operating systems that might differ, although they don't sometimes, any newly created objects are owned by whoever created those objects. So if you're logged in as root and you create an object, it's going to be owned by root until you start passing that around. And then you can pass privileges, you can grant privileges. That's what we call it in SQL. So I could say I grant select to you, and that way you can select from the table. Right? And usually the privileges we grant are named the same as the actions we can invoke. So grant, select, and update, and delete, and things like this. Right? Now, privileges are also grantable. So we can say, I can say, grant you select, and allow you, with grant option, to pass that on to someone else. Right? And these things will be propagated around like this, just in like a sort of Active Directory situation where we have delegation of roles. Right? And I can, for example, grant access or select or update access to very specific columns in a relation as well. So you can be quite explicit about this. The only thing to know is that, the only thing, sort of little niche thing that you might want to know is that when I grant permissions to you and allow you to grant them to others, if I revoke your permissions, it will cascade along and revoke everyone else's permissions as well. Right, so that's just something to bear in mind. Okay. So the thing that I'm kind of interested in SQL is view-based security, because I think it's quite a good idea, it's quite clever, it's something you don't get from data, where it's basic, for me, it's something that separates SQL a little bit from normal file access. Because if you just have access to a table, at the end of the day, you're just listing data, right? It doesn't really matter that it's formatted like a table. A view, they're derived relations. So essentially what it is some kind of select query, or join, or something like this, where we then create a new intermediate table based on that, right? So I've got this example here. Let's imagine that I'm, I don't know, working at a hospital or a drug company or something, or maybe I'm working at a care home, something like this, right? Now the care home, lots of the people who live there are on various kinds of medication, right? But maybe my role is such that I don't have access to exactly what medications are on for confidentiality reasons. Right? Now, if that's the case, it's going to be difficult for me to order the next month's drug supply because I don't know how many of each drug to get. Right? So in our situation, what we do to avoid that is we say, okay, this person, so me in this instance, is allowed to look at the totals of all these drugs, but not exactly who has access to which drug and who's on which drug and how much drug they're on. Right? All I need to know is, this is the list of drugs to send off to the pharmacy to order this month. Right? So we create a view. So we create a view called farm order, which is as a select from, we're selecting the drug database name and the sum of all the totals, right, from patients, comma, drugs. So that's a join between the patients table and the drug table. Right, I made this up, by the way, so let's not worry too much about the SQL. Right? Grouping by drug name. So what we're essentially doing, right, for those of you that haven't seen SQL before, is we're saying, right, let's go through all the patients and drug database and find essentially what drugs everyone's on, right? Group by drug name, and then sum them, right? So that we basically say how many of each drug are we on, right? Roughly speaking. Right? Now, exactly what this will do will depend on the database, right? Now, I'll talk about check option in a minute. So what this is doing is creating me a new view which just gives me names of the drugs and the number of drugs that I need, right? I can't look in that view and find out anything about the patients because I don't have access to the patients table. Right? That's an intermediate thing. It's like me in an operating system having access to some application that reads from a file but gives me only some of the data. Right? Kind of like that. And this is quite a nice way of doing it because you can create quite complicated views, first of all for convenience, because maybe me writing this query every time is a bit of a pain and I don't know how to use SQL. Right? So that's a problem. But also, we can have then select, update, delete access granted to views as well. Right? So we can have nice abstracted views of the data, but give each individual person the specific view that they're allowed to have and nothing more. Right? For me, this is kind of an instance of something called the principle of least privilege, which is the idea of only giving something or someone the exact amount of access they require to do the task and not anything more. Right? This is why in Linux you don't tend to log in as root, because if you logged in as root, you can do anything you want. And most of the time you don't actually need to do those things. It doesn't make any sense. Right? Use root when you need to use root, otherwise don't. Right? When you're writing a Word document in Windows, you don't need to be logged on as an administrator. Right? We just use that at the time. And this is all the more true in databases. So when would we use views? Well, they're a very nice way of creating policies, security policies on our relations that are very close to application requirements. So let's say that we have an application that is going to handle this ordering for us. Right? We can create a view, and that application then has exactly what it needs to perform that task and nothing more. And it also means if there's a problem with that application, like a bug or something like that, nothing really can go wrong. Right? Because all it can do is view the totals of drugs. It can't glean any information on the patients from that. Right? So this is kind of like controlled invocation. In some ways, what we're saying is, remember back in sort of kernel security, we were saying to the operating system, could we read this file, please? And it would go away and read it on our behalf and return us a result. Or could we write to the screen, and it would go away and do that and return a result. And here, what we're saying is, we'd like the totals of the drugs. Right? It's going away and looking at the actual privileged data and returning a result. Right? So it's a very nice way of performing controlled invocation. It's also, as it happens, quite an easy way to reclassify information. So if we decide suddenly this person isn't allowed to perform this kind of view of the data, we just delete the view, or we just revoke their access to the view. Right? It's much easier to have lots of people tied to lots of views than it is to have everyone running obscure select queries, and we don't know exactly what they have access to and exactly what they don't. Right? So this kind of security is a good way of doing it. Right. So when wouldn't we use views? Well, so insert and update, they can get quite complicated quite quickly. That's one problem, right? So insert and update actions, you can insert into a view, but of course, if that view is a join of multiple tables with where clauses, that's kind of confusing, right? It's not absolutely clear sometimes what the best way of the database management system handling that is, right? So we often have this thing called with check option, which basically enforces the check that you can't insert into a view something you wouldn't be able to look at in that view. So I'll give you an example, right? Let's imagine that I'm an accountant and I work for the HR department of Nottingham, and I have access to the salary database because I can look at, let's say, everyone who earns less than 50,000, right? I don't know why. I'm making this up. Now, so I have a view that says select from, staff where salary less than 50,000, right? And it's a view, and I have access to it. Now, suppose I want to update someone's salary because they've just been promoted, and I adjust their salary, I update that view for their salary to be greater than 50,000. Well, suddenly, they're going to be outside of that view, and yet I've just updated them. And there's a contradiction there, because I'm not allowed to look at or know the salaries of people who earn over 50,000. And yet I do know that because I just inserted it into the database. Right? So what that will do is throw an error and not let me update that value. Right? Someone else will have to do it, or they have to remove my restrictions. Right? It just is a way of preventing people getting databases into confusing states where they're updating fields blind and can't actually see what the result is. Right? Because essentially that's just going to lead to problems down the line. Right? It's not a disaster if I know whose salary is over 50,000, but it's not brilliant. Right? So blind inserts are something we try and avoid, but they do happen with views. Right? If you have full access to a table, it's not possible to make a blind insert because you can see everything. Right? Okay. Just like with, I don't know if you were told this when you were learning about databases, but just like with regular databases, views do not achieve consistency by default. Right? This is the problem with SQL, is people think that they've got a nice table with foreign keys and things that point to other tables, and so inherently this is nice and consistent. Well, that's not really true. In sort of a data sense, it's probably consistent, but having the information be consistent is really up to the administrator. So, for example, database consistency means that the information stored in your database is a good representation of what it was meant to be, right? So of the world. And so, for example, I could set someone's date of birth to be the incorrect value, and that isn't consistent, but that's kind of on me as an administrator. You can't do much about that with views, right? But so that's the point. It's not inherently a drawback with views. It's just something we should be aware of. If the administrator's going and messing around, right, it's not going to enforce database consistency because that's not the function they perform, right? So it's just worth remembering. They also can become quite inefficient, right? You can imagine that I've got my pharmacy view, which looks like this. That's a join of two tables. For a small care home, that's not going to be a big deal. But if you've got a join between a table of 1 million rows and a table with 10 million rows or something, and then I have a view on that, and then a select based on that, and then another view on that, it's going to get inefficient very, very quickly. Now, database management systems are programmed quite well, and they will optimize queries, and they will cache intermediate tables. But it's just worth bearing in mind that if you start using views a lot, you're kind of hiding away the fact that there's quite a lot of processing going on behind the scenes, and you just have to bear that in mind, right? Things get slow nice and quickly. Okay. So that's kind of all there is I'm going to cover on privileges and views and things like that, right? Hopefully that's nice and clear. If you didn't learn about privileges and views in the first year, then obviously that won't be clear, and so you should ask me about it, and I'll tell you. Okay. All right, we're going to cover something a little bit different now. These are statistical databases, which is hard for me to say apparently. This is the idea that maybe there's a database where we want to perform some kind of aggregate query, like a sum or a total or an average, right? But we don't actually want to have access to the individual rows. So 2 examples that come to mind. One is medical records or drugs. I want to know how many drugs there are in a hospital, but I don't want to know who's on what drugs, because I'm not allowed. Right? And that's patient confidentiality. Another example would be perhaps the taxman, right? He needs to know how much the staff are paid at Nottingham so that he can organise tax, but he doesn't necessarily, each individual isn't necessarily meant to know how much everyone else earns. Right? Let's think, what else have we got? I had another one, but it's gone. It will come back to me in a minute. Right? There's lots of reasons why you might have these kind of aggregate query databases. Right? Now, so these are actual systems, right? But think of it basically like a view on front of an SQL database, where all you can do is calculate things that don't show individual row data, right? Oh, I thought of it. It's census data, right? Census data, it's quite common to poll census data, but you're not allowed to know where I live or what, how many children I have and all this sort of stuff. But you can know how many children there are in this part of the UK, or how many people of a certain age there are in this part of the UK, right? So aggregate queries on census data, very common. Individual lookups on census data, not allowed, right? Depending on who you are. Okay. So, yeah, it came back to me. Now, so statistical databases are a thing, and they've caused a huge problem for security over a number of years, and that's because it's very easy to game these databases and find out all the information you want to know. Right? So, for example, if you want to know from the census data how many children an individual has, you just do some kind of select query, selecting the total number of children in this house. Right? And what you've done is you've kind of used a where clause that's narrowed it down, and even though you're running a total, it's kind of cheating. Right? And there's no real good solution to this. You can try and make your database system aware of the fact that people might try and do this, but there's no good way of routinely, every time, spotting that someone is doing something that could result in them gleaning some information on individuals. Right? So this is the problem of inference. Right? We need to have access to the data, and we need them not to be able to infer any information they shouldn't have from all these queries, but actually it's surprisingly easy to do. Right? So statistical queries are very, very useful, so we have to be able to do these things, right? But by definition, they refer to the underlying data, and so in a sense, we are getting too much information. Right? So this is called a covert channel. A covert channel is essentially an unintended side channel from some data or a data source that's leaking information, right? Similar to a side channel, but we tend to call it a covert channel because they don't know it exists, right? And they found out that, I'm sort of missing a slide here, I don't know whether I deleted it or not, which is why I'm a bit confused. Basically, in about the 80s and 90s, statistical databases started to become more popular, and the security of statistical databases became a big concern. But basically, they gave up, right? Because there's always an attack you can run on statistical databases, and it's very hard to know how to stop it, right? So they came up with some ideas, and they updated these systems, but they just kind of gave up. Now, as statistical databases have come back into fashion, people keep doing this, and they keep saying, how can we fix these problems? And again, they become really hard, right? So I'll show you an example which shows you just how hard this is to do, and you'll sort of hopefully see the problem we're looking at. Let's imagine that I work in the accounting department again, right? And I can sort of query the sum of all salaries in the department or something like that. Now I decide, because I'm nosy, that I want to know what the head of school's salary is, or the head of department, or whatever it is. Right? Now, I'm not allowed to know that, because that's beyond my pay grade or whatever. Right? So how am I going to do this? Well, the first thing I could do is I could say, right, let's do a query that says what was the sum of all the salaries in the department, so everyone added together, right? And then, what is the sum of all the salaries in the department except anyone whose position is department head, right? Now, it should be pretty obvious what that's doing. It's essentially a sort of Venn diagram situation where you've got all the salaries here, and you've got all the salaries minus the department head, and then you've got this guy in the middle whose salary we can calculate, right? It's that kind of situation. So we can just calculate the boss's salary as S minus T, right? Now, that shouldn't be allowed. So maybe the person that designed this statistical database went, okay, hang on a minute. What we'll do, we can fix this, right? What we'll do is we won't allow any sets of just one, right? So these lead to a set of, this here is a set of just one, people who have department head as position, so we won't allow that, and that query would be rejected, right? That can be easily built into a statistical database, where if you have a where clause that leads to a set of just one, we say, no, not allowed, right? Because that's too much information you're gaining from that, right? Okay, so what we do is we go back to square one, right? And the accountant says, well, okay, so let's do the sum of all salaries, right? So far, so good. Then we'll say we want all the salaries of any women in the department, plus anyone whose first name is Albert, right? Of which we know there's only one, right? And then we say, okay, let's have the sum of all men's department salaries. Now, nowhere here is there a set of just one, right? So then we do T plus U minus S, and we have Albert's salary again, right? So the defense mechanism did nothing, right? But it was a start. Okay, so how do we fix this? Well, what we can say is we'll have a think, and we'll say, right, let's not allow any conditions that refer to just one, right? So here, there's a condition here, someone whose first name is Albert. That's a condition, a where condition that says there's only one of those people. Let's block that, right? So that wouldn't be allowed. Okay, so far so good. All right, so we'll step it up a notch, a little bit, right? And we'll say, okay, let's start with S is the sum of all salaries. Then we do a query that says, what is the number of department heads named Albert? And that query is blocked, right? Which tells us that there's only one, because we're not allowed sets of just one. So what we've done there is use the existence of information as a clue rather than the actual information itself. So remember, it's quite easy to infer data. Do you remember when I talked about the idea of the difference in the error message between this person has a criminal record and this criminal record does not exist? Sorry, you're not allowed to access this criminal record, or this criminal record does not exist. They're two very different error messages with very different meanings, right? This is one of those times. So T is the sum of all salaries for anyone named Albert, right? Let's say we've scaled this up now to the whole faculty, just to be safe, right? So we're now looking at the Faculty of Science. There are more than one person called Albert, apparently, who works in the Faculty of Science. So far, so good. U is the sum of all salaries for all department heads. There's more than one of those. So far, so good. V is the sum of all salaries for anyone who are not department heads or named Albert, of which there are plenty, right? And so then we calculate V plus T plus U minus S, and we have Albert's salary again. Right? So there's no stopping this. This is called a generalized tracker attack, right? And we're totally stuffed. So I have no solution to that, by the way. If you think of one, you'll get lots of citations in your publication. Right? There are a few ways we could think about trying to stop this, right? But it's a big problem because statistical databases in research and things are quite a good idea. And maybe you want to try and anonymize data. In medical research, you can imagine anonymizing data is pretty important. It's going to be common to have 500 rows or 5,000 rows on patients, and you don't really want to be able to link that back to individuals. You just want to be able to say the average condition is this and the average something is this. Right? So there's a few things we can do. Right? Yes, we can put in some arbitrary rules like this, but maybe we'll weed out the really obvious attacks. But what they showed was that there's something called a generalized tracker attack, which is essentially a mathematical version of this. And they showed that there's basically one on every possible database. So there's no amount of rules you can put in that will stop you from doing some arbitrary union and disjoint sort of intersection of sets that would prevent this. So what do? Well, the first thing we could do is data swap, right? So if you have any queries with a few number of people in, you just return different people with different diseases and things like that, or different people in different salaries. And that means when you calculate the average salary, your result is exactly the same, but an individual salary is random and unusable, right? So that's one thing we could do. Now, Whether or not you can do that is going to depend somewhat on the kind of data you're looking at, right? It might be quite important not to switch people around if you're talking about cancer diagnoses, right? But it might be okay if you're talking about salaries and all you're doing is calculating their total salary, right? So that's one thing you can do. Option 2, right, which I don't much care for, is you could add noise to any of your aggregate queries. So if you add a random amount of error to every single query, like the count, the total, the sum, right, then you can't take one away from the other and get a realistic answer for any individual salary. Now, of course, again, whether or not you can use that is going to depend a little bit on what the situation is, right? I don't think you can go to the HMRC and say, this is how much staff have been paid at Nottingham, plus or minus a few million, because we didn't want to make it insecure, right? Because they might frown upon that. Right? Obviously, we could split the table up. If you don't want people linking salaries to individuals, then don't store the salaries with the individuals. Right? Store them in a separate table and have different people assigned for those tables. Right? You know, so essentially database normalization for security, right? Or views. Right? And finally, what we could do is we could log queries. So we could say, okay, we can't stop this, but we will at least fire the people that do it, and that might prevent them. Right? So what we do is we log any queries, and then we work out if any of them could have been used to leak information out. Of course, that's quite hard to do. Some statistical databases will track queries and over time build up a picture of these intersections and work out if someone's stumbling across too much information beyond their pay grade. Right? Now that's, again, hard to do. And there's an issue of sort of false positives here. Let's imagine that what's the timeout on that, right? If it's every week, right, if you keep a log of all the queries I put in each week, I'll just do this over a period of 6 months. People's salaries don't change that much. It'll get through, right? If you have a huge window, then maybe I find 2 years down the line that one of my queries is blocked because of some obscure set intersection that I didn't realise existed from 6 months before, right? And I wasn't doing anything nefarious. Okay? So this is not a solved problem. Right? So the conclusion is I don't have any solutions to this. I'm just telling you about the problem, and you can go away and solve it and come back to me. Good. All right. So let's talk a little bit about SQL injection, because it's fun. I'll let you read this. You'll have seen it before, but if you haven't, please do have a read. So I like XKCD. I don't read XKCD all the time, but this is one of the better ones. Of course, it's quite famous. It's not absolutely correct, because the issue is not just that they haven't sanitized their input, it's also that they haven't used the principle of least privilege. However, let's not be pedantic. An SQL injection is very much like an XSS. Right? The idea is that what we're doing is we have control over some kind of string that's going into SQL, it's getting interpreted as a command and then executed. Right? And that's a very big problem. So, for example, and it's a problem because it's very common to interface with SQL via strings. Right? It's less so now because people are trying to focus on parameterized queries, but it happens all the time because people just whip up a database really quickly and job done, it works. Right? I'm an example of someone that does this. So, here's an example of some PHP code, which is not very good, but gives you an idea of how we might interface with a database. So, we're trying to find a product in a list of products. We've got a search box. So what we're going to do is select all from products where the product name is like some search term that the user's entered in their search box, right? And these two % symbols are wildcards, which mean that the search term can appear inside a string rather than just at the ends. That's very common. Now the problem is that I have control over this search term as a user. And so I can put in things like SQL commands, and they might get executed. That's where we have a problem. Right. So this is very similar to XSS, except instead of injecting scripts into HTML, we're injecting SQL into SQL. Right. So, for example, we could say, just to use to continue on from the XKCD, we could say, well, if I type in semicolon, quote semicolon drop table products comment, right, then what that's going to do is search for a product like anything and then drop the products table, right? Which, of course, if you haven't implemented principle of least privilege, will actually happen, and then that's a huge problem, right? It goes without saying that's a huge problem. So an SQL injection attack works when let's assume for a minute that the database is accessed without like proper permissions and views, right? Because they're not going to have done that if they haven't sanitized the input either. Right? At any time that you see an SQL control character, you need to be escaping that character so that it goes in as a string rather than as an executable command. Right? So the classic example is a single quote. Right? That represents in SQL the beginning or end of a string, whereas if you're searching for O'Reilly's nails or something like that with an actual single quote in, you need to put a backslash in front of it to make sure that it's escaped. Right? SQL interprets backslash single quote as a sort of physical single quote character, not as the end of a string, which is exactly what we want. Right? That's what should happen. Right? So let's look at an example involving my login page. Right? So this is my login page that I showed when we were talking about user authentication. Right? So we said that maybe you type in your username here, and then what happens is it selects the hash from users where UID equals username. Right? And that's what they've typed in, so Mike or whatever. Right? Now, that goes into the database, looks up the username, and then we compare the hashes and they authenticate. Right? So far, so good. So the problem is that if we don't sanitize this input, then this gets used in this query, this username field, and I have control over this string here, and that could be a problem. Right? So something like this. If I type in Michael as a username, then the query becomes where UID equals Michael, and that's absolutely fine. My hash gets returned, and I get logged in or not logged in as appropriate. Right? If I type in something like this, right, Michael, single quote, create user, blah, 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 then what I've done is I've split the single SQL query into three. The first one selects my hash. The next one creates a new user with that as the password. And the next one gives them all access to all the tables and databases. Right? A problem. Right? Now, this won't always work. It depends on the way that the database management system is set up. It depends on what the output and the way that the PHP works. But you get the idea. Right? And you can take it a little bit further than this. Right? So you could, for example, do a blind SQL injection. Some of the time, you'll just get a list of things on the screen that you can manipulate using SQL injection. That won't happen all the time. Right? So a blind SQL injection is one where we use timing attacks or other information like the success or failure of a website to decide whether or not we're getting closer with our attacks. Right? So for example, let's imagine there's a shop, shop.com/items.php, ID equals 2. Right? And let's imagine that is the method that this shop uses to list like summary of items or what have you. Right? So if I have ID equals 2 here, it will show me a page about ID item 2, right? Whatever that is. Right? A car or something. Now, so if I do this, ID equals 2 and 1 equals 1, right, and that returns item 2, then I know that this is SQL injectable, and yet I haven't got any actual sort of this is SQL injectable code back or any special like database errors or anything like this. Right? The fact that it's returned item 2 tells me that this is working, because otherwise it wouldn't have returned item 2. Right. Similarly, if I say and 1 equals 2, this will return no items found, even though there is an item 2 because I just saw it. Right? And that's because this is executing this as a second part of this where statement, and that's something I can use to my advantage. Right? Now, not that you should try this at home, but if you do, you need to replace these spaces with %20. Just as a sort of small FYI. Right. Escape HTML. Now, so we can use this ability to fingerprint. So, for example, we could say, we could make a query where we say ID equals 2 and table equals username or something like that, and then it will return item 2 if there's a table called that or if not. Right? So we can start to fingerprint the names of tables without actually being able to list the names of tables on the screen. Right? That's what a blind SQL injection is about. We can also decide which SQL management system we're running. Right, which database management system. So, for example, if we do this, wait for delay, that only works in SQL Server. Right? That's a command in SQL Server to wait 10 seconds. In MySQL, it's sleep, so we can try it with that and so on. We can try all these attacks and we can work out what the database management system is that's running. Okay. Once we know what the database management system is, they all have metadata tables. We can look into these and we can filter out them this way. So this, for example, will say, look, I want ID 2, and where 1 is equal to the count of anything in information schema.tables where table name equals users. So this is what I was just talking about. Right? What this will do, have a look and see if you can work out what it does. Right? the information schema.tables in MySQL is a table of all the tables. Right? So far, so good. Any users tables are going to return a row, and we're going to count those rows and see if there's one of them. And if there is, we know there's a table called users in this database, right? Simply because item 2 returns or item 2 doesn't return, right? There's no list out that tells us what the table name is. We've just inferred it. So you just try users, user, people, staff, and you just try a few different names until you find the ones you want, and you can start to fingerprint exactly what's going on underneath without any output at all, right? I say you can do this. There's scripts that will let you do it. Right? I'll show you one at the end. Okay. You can also use union attacks. These are very common. So a union in database SQL is essentially a set intersection. However, for the sake of argument, we'll just simplify it by saying you stick one table on top of another one. So if you have a table with 3 columns that's coming out with products in, you can start to output additional information underneath that table by unioning, performing a union, that's the one, with another subquery, right? So, for example, if we have here, we're doing a search where all returns are hammers and nails, that's going to return some table of items. We can add this union select one IDs hashes from users, and that will append all the IDs and hashes of the users underneath, right? Assuming that table exists. So far so good. Right, these are some of the things you can do. So this is not a blind SQL injection. This is just a regular SQL injection. Right? And then finally, we have second-order SQL injections. So let's imagine that maybe it's not totally incompetent, this website. Right? They've escaped or used parameterized queries on the first input. So now we want to try and get in underneath. So what we do is it's about putting something in the database that gets executed later. Right? And the first time it goes in, it's not executed. It's the second time it comes out, it's executed. So let's imagine that I decide to create a new website, a new user on a forum, right? And I want to SQL inject this forum. Now, I try SQL injecting the username and the create login. It doesn't work, right? Because they've actually coded that properly. So I create a new user, and I call them admin quote dash dash, right? Admin with a single quote and a dash comment after it. Now that's allowed because they've escaped those characters, and also because there is no admin quote dash dash username, right? Admin is already a username, but that's neither here nor there. So then I decide later that I've forgotten my password and I want to change my password. So I click forgot password link, and it updates my password. Update users set password equals new password, where username equals admin comment, right? And I've changed the admin password for the forum, having not actually got the username of admin. You see? So this is a very contrived example, but the point is that a second-order SQL injection is one where I initially put some executable command into the database, and then it gets executed at a later date. So essentially, what I'm saying is don't just sanitize your inputs, but sanitize things that are now coming out of a database and going back in, right, to stop from second-order SQL injections. Okay, so let's demonstrate this. I've written another of my brilliant websites. Right, the template is exactly... Oh, no, it's not. There we go. Right, the template is almost exactly the same as the one I showed you before. It's just it's orange this time. So this is a shop I wrote. Right, it's not very good. So we can find things like burgers. Let's try that. There we go, 0. Burger. There we go, it's not very good. Burgers doesn't work. Right, so it's got some food in there or something, I don't know. Now, I'll make this a bit bigger so you can see it, because, I've used fancy, vague grey text. Control. How do I zoom in? Ah, there we go, how's that? Good, all right. Okay, so, now this shop, this, like my blog, is not well programmed, right? So if I put a single quote in here, and I search for it, it doesn't escape that single quote, and it causes a server error, right? So when you contact the authorities. Now, so that's a bit of a problem, because that means that I can theoretically SQL inject into this box, right? So the way that I would go about this is I would construct an SQL query in my head about what we think is going on underneath the hood, as it were, and then test around and play around until we get it. So I'm going to bring up Sublime. Right, so I think that the select query, hopefully you can see that, is going to look a little something like this. Given that if we search a burger, right, we're getting some burgers back, and there's 3 columns, right? So we're just going to sort of start guessing. So we could say, I don't know, select some amount of columns, probably 3, but let's see. from some table, which is something to do with products or something, where some column name specifically is like burger, right? Something like that. Now, actually, if I type in urge in here, which is the middle letters of burger, you'll see that it finds the burgers, right? Which means we've got wildcards. So I can put them in as well. So that's going to be something like that, right? So that is what we think the query looks like. Right? This is how you start. Now, the question is, I have control over specifically this bit of text here that I've highlighted. I don't know if you can see it. Right, between the wildcards. The wildcards are part of PHP, and I haven't got control over them. They're going to be in there whether I like it or not. Right? So I have to either escape them out or comment them out or what have you. So if I put a single quote in, you can see what happens is it just breaks. Because now it's saying, select something from here like anything, and then just some stuff that doesn't compile and throws an error, right? Which is why we get server error. Apologies for the inconvenience. So what's the first few things we can do? Well, the first thing to do, I suppose, is to just sort of mess about. So we could say and 1 equals 1. Equals 1, colon, comment, right? Something like that. In fact, let's put burger back in. Why not? There we go. Right. So this is going to be, this should execute, right? Because what we're saying is, find any columns where the row is like burger, with burger as the last word, which is, of course, all those burgers as well. So let's copy that. So I'm going to copy from here all the way to the end of my comment. Comments in SQL are a dash space for some reason I've never quite understood. Maybe dash is used for something else. Right, so let's put that in. Now that should still work, right? But if I put in, so that worked fine because the 1 equals 1 returns true every time, right? But if I put 1 equals 0, for example, that should return no products. Right? And that's because it found the burgers. If I look at my query, it found the burgers here, and then it said, well, is 1 equals 0? And the answer was no, and so it never returned any products. Right? Definitely don't go this far on someone else's website. All right. I'm going to keep saying that. Really bad news. Now, so what can I do next? Well, let's find out what database management system we're running. Now, we haven't got that much time, so let's pretend I know secretly that we're using MySQL, right? Because it's running here. Oh no, that's SQL map. That's a different thing. Never mind that. So, now the sleep function in SQL, MySQL, returns 0 when it returns, but it also sleeps for 2 seconds. So what's going to happen here? Let's put in another wild card just to make sure I know what I'm doing. Okay. So what we're going to say is okay, return from this table like burger. So that's the 3 burgers that we saw before, and sleep where sleep returns 0, which it does. Right, but sleep for 2 seconds. Now, there are 3 burgers, right? And the way the if statements in any of these languages are calculated is you do the bit on the left first and then the second bit on the right. So for each burger, it's going to sleep 2. So it's going to sleep for 6 seconds. Right? That's kind of my hypothesis. Right, if it doesn't, I've made a horrible mistake. There we go. So copy that. I like doing it in here because then I just copy and paste. Typing in this is a bit confusing because I don't get the colour highlighting. Right, it's waiting. 4, 3, 4... 5, 6. Yeah. Good. Right, that's not a good sign either. So, we're getting there. We haven't actually got that many queries to go, right, because SQL injection is super easy. So now what we're going to do, now we know it's MySQL, we can start polling the information schema. The information schema is the name for MySQL's big database of everything, including all the names of all the tables and all the names of all the databases. Right? I mean, maybe the first thing we could do is see if we can perform a union. Right, so we're going to select where anything is like burger, right? And then we can say union, colon, quote, select 1, 2, 3 from Joule. Now, Joule in MySQL is the name of the table you use when you don't have a real table to draw from. Right? I don't know why it's called Joule. So what that's going to do is select the numbers 1, 2, and 3 and return them in a single row. Right? And hopefully, because we've got 3 columns in our table, that will just sit nicely underneath. Let's see. So we're going to take that here after the comment. Remember, we have to conclude this comment at the end, because if we don't, this wildcard and single quote is going to cause a problem when it comes to PHP. So, there we go. Right. So now, this is no longer a blind SQL injection. Now we're actually just outputting stuff to the screen. That's bad news. Right. So we're nearly there. So we can find out what the database is called by, instead of selecting 1, we can select database, right? Because there's a nice handy MySQL function for just telling us what the current database is. All right, so let's copy that. This is why 15-year-olds get into websites with MySQL injections. Shop, right? That was, I mean, that we could have guessed that probably, right? It's got it written in big letters at the top. Never mind. So now we're talking about the database shop. What are the names of the tables we're interested in? Okay, now I happen to know also that in MySQL you can poll the information schema.tables table to get the tables. Right? So we can say select table name from, here we go, information schema.tables. It's gone purple, which I think is a good sign, reassuring, where table schema equals shop. Right? So for this database. And we'll just copy this. There. Nope. It's trying to be clever. There we are. Copy that. Paste that in there. Yeah. Okay. So within our shop database, we have two tables. One called stock, which I presume holds the burgers, right? And one called users, which I presume does not hold the burgers. So we're going to focus on the users table, because obviously... otherwise, this would just be me doing more searches for burgers. So we're going to try and find out what the column names are in that table. Right? So select column name. We can just use 2 and 3 to make sure that the union works. Now, can anyone guess what the information schema dot is? I want the column name. It's going to be columns. Yeah, see? Yeah. There's logic here. Where table name is, and what was it? Users. Okay. We don't have to set the database because the database is already set up. Right? Now, if this were escaped, I couldn't do this. But if the principle of least privilege was used, I also couldn't do this because there's no reason that this burger shop is polling out of the users table. Right? Don't do that. So there's lots of things wrong with this. All right, I've got an error in my code. Table name. Columns. Columns. Oh, pound. Right, here we go. Okay, good. We're one away. Okay, so we know that we've got an ID. That's obviously an auto-increment column for the primary key. We've got uhash, utype, uname. These all sound relevant to me. Okay, so let's put them in. Okay, so... not SQL map, that's the wrong place. So we're going to go in here and we're going to say select uname, uhash, hash, utype from, not from the information schema anymore, just from users. Right, it's that easy. There we go. Copy that. Oh, come on. Oh, it was inevitable, wasn't it? So, it looks good to me. No. No, I thought I had it. I don't have it. If I can't get it working, I've got a backup plan. Oh, come on. I've always done this. It's probably the first time, year 4. Oh, I don't know. Users. Okay, it's definitely not going to work. All right, well, we won't do it. I'll do it later, right? Or I'll just link to a video of me doing it last year. But I will show you one last thing, because I don't need to do all this, right? Because in 2015, a 15-year-old hacked TalkTalk with an SQL injection, but he didn't write any of it himself. He used SQL map, and I just wanted to show you what you do, right? So you do something like this. So you say, you run SQL map. It's basically the script kiddie version of what I just did, also it works, right? So I'm going to SQL map. Yeah, that looks all right. So I'm going to say, right, I'm going to SQL map The URL is going to be http://localhost/shop, okay, and the data is keyword, because this is a post, burger. Right? And what it's going to do is it's going to do all of those things I just did and automatically for me. So look, the keyword is vulnerable. Would you like to keep testing? Nah, I'll probably just keep going with what I am actually, thanks. Right, so it's found that, okay, now what I need to do is I need to return the list of, I want to learn what the database is running. Okay, so that is, there we go, we've got the information schema, shop and test. So I'm going to use shop, so I'm going to say, given the database shop, give me a list of tables. There you go, stock and users. All right, given the database shop and the table users, dump. And we get all the hashes out. All right, that's why you need to secure your sanitize your inputs. I'm done, thank you. Okay, cheers everyone, I'll see you next week.